Good morning all, it's Postbag, and today a random selection. I'm not going to theme this or anything like that. So let's start with this one. Oh, that didn't cut very well. It's quite fat. Well, I can't work out from these smudgy images what that is, so let's take a look. Right, well I've got 5 of these 8161 little kits, and they are just stereo audio connector kits. So you've got 2 RCAs, a right and a left. You've got a JST connector there, which will have ground in the middle, right and left. There's a 3-pin sort of terminal block, and there's also a kind of headphone socket, which presumably is also stereo, and they're all just commoned together, paralleled together on this little circuit board so that you can make audio interconnections. Now I bought 5 of those, and I got one of this, which is a 10756, and that appears to be a stereo volume control, so presumably a logarithmic stereo pot. And the cable, and I don't think I wanted the pot, I think I just wanted the cable. But I can see a problem with this immediately. The cable connectors are a different pitch to these connectors. I'll open them up. So it's this usual problem with JST connectors. This one I think is the XH, which is 2.54 millimeter, or a 1/10 of an inch pitch between the pins. And the one on this pot board I think is probably the 2 millimeter. So the cable that I wanted is not going to fit that connector. That's not going to work. And I think the motivation for all this was this first karaoke reverb board that I bought, which has these JSTs as the audio inputs and outputs. And I just soldered wires on to the connections underneath and used crocodile clip cables, and it was all a bit of a mess. And so what I wanted to do was use these breakouts, which can convert from the JST into RCA phonos. And then we can use, well, there's the little 3.5 millimeter stereo connector as well in there. The subsequent karaoke board that I bought, which is a much bigger board, does have RCA phonos on here. This one also has the single 12-volt power supply, or I think it's a range of voltages. This one you had to have a split power supply, something 0 and minus something, 12 I think, to, what does it say on here? AC 6 volts to 20 volts it says in there actually, so quite a wide range. But this one more versatile with the better connections. But in order to use this one I wanted some of these, but I wanted a supply of cables which were done as stereo audio. In other words, they had the ground in the middle and the right and left channels on the outside, and the ground was the braid on the cable. Nevertheless, these are pretty neat boards. I think I found a supply of the 2.54 millimeter grounded stereo cables. I think that's in my watch list or eBay cart or something. These are all marked up with left, ground and right. I presume red is right on the phono, and left and right are predefined, of course, in the 3.5 millimeter jack. So yeah, I'm going to make up a few of these and just see if I can find some alternative cables. The little volume board is just a dual gang or stereo potentiometer on a board. I presume that's a logarithmic taper potentiometer rather than linear. You can see the 2 sets of 3 pins, so 6 pins in total. You've got an in and an out, presumably because the outs are connected to the wipers and the ins are connected to the, well, the full volume position, which is on this side. So the ins go to the full volume position, and then when you turn this down to minimum, of course the wipers are connected to ground. So the one I bought is no longer for sale, but I bought it from this seller, ASP eZone, and this is an almost identical kit. 5 pieces DIY kit audio switchboard. Not a switchboard, more of a distribution board really. RCA 3.5 millimeter audio input block 4 amplifier. $4.50 for the 5 pieces, free shipping. Now the colour of the connectors is slightly different in this image, although this image shows that original blue terminal block, so that one is identical actually to the one that I bought. And the other item is this. It's double plug wire plus volume control potentiometer board for DIY amplifier board. $2.20. That includes the board with the dual gang potentiometer and the cable. Free shipping, and that's also from ASP eZone. But down in the description, it says input 2.54mm socket, output 2.54mm socket, but I don't think it is. Because if you look at the image at the top, let's have a look at this connector, for example. The one next to the potentiometer, I can't point at it. I'll point at it here. The one next to the potentiometer, it kind of covers both the green sections and half of the silver section. And that's identical to the one I've got. So yeah, you can see that the socket there is both the green sections and half of the silver section, and this is not a 2.54mm socket, it's a 2mm socket, so just be a little bit careful. I don't think that item is going to be quite exactly as described. Right, here's another one, randomly selected, no identifying mark, so I can't work out what it is. It's that. Right, this is I think a 5-volt in to plus and minus something out. Obviously adjustable. Those pots are different though. That's a 203 and that's a 502. And the regulators are different. They're both XL semi. These will be switch mode regulators. One is a, oh, I can't quite read that. Something 008. I can't read the other one. Perhaps I'll get the magnifying glass. Right, yes, the one on the left is, and I assume that relates to the VCC, in other words, the positive supply. That's an XL 6008. The one on the other side is an XL 4003. No, one's not quite double the other. Some inductors there, which just look like silver blocks with 470 on them, so 47 microhenries. Another couple of silver blocks near the output connector there, so I assume they're also inductors, but there's very little in the way of sort of identifying marks. Well, there are no identifying marks, so I have no idea what value they are, but pretty sure they're inductors. Lots of these really tall multi-layer ceramic capacitors, so they're doing all the smoothing. No electrolytics on here at all. Oh yeah, there is one on the input. Well, I assume that's on the input, although it's rated for 35 volts, but that looks like it's near the input. There's even some stuff on the back there, a few resistors, capacitors, and a diode. Right, well, let's power this thing up with some 5 volts, and a red LED comes on. That's fine. Now I suppose what I should do is check the two output voltages and see what they are and what they can go up to. So what are they set to initially? Well, the positive side seems to be set to 11.2 volts. And the negative side is set to 11.2 volts. Not quite sure why. Let's see if they'll go to 12 volts. Right, let's use the Bourne's trim pot. You can't actually get them like this anymore. This is a very old vintage, 1985, I think, given to me when I was a field service engineer. But if you look for an H90 or an H91, you can find something very similar. So let's twiddle that pot. Well, I'm going anti-clockwise, and that seems to be going up. Oh wow, that's going up alarmingly. And I'm not really sure what the spec of this is in terms of things like the capacitors. They're ceramics, so they should have a fairly high voltage rating, but that's... oh, that's topped out at 30 volts. Okay, that's fine. So let's go the other way. Well, presumably I can take this all the way down to near 0. Oh, that's not anywhere near linear. Oh, and that's dropped out at... yes, I suppose the point about these is that they're boost converters, so it's not going to be able to go much less than what's coming in. So that's bottomed out at 4.8 volts. Well, I'm trying to adjust this one back to 12 volts, but at this position, these pots are extremely sensitive, which maybe it was set for 12 volts initially. Oh, I'm going the wrong way. Anti-clockwise for increase. And they just drifted a bit, but yeah, I'm not turning that very much at all. Tiny movement. and that's moving with quite large swings, so it's a difficult thing to set very exactly. And there we are, both sides set for about 12.1 volts. Now there are a couple of pads on the board there marked E- and E+, and I imagine those go off to the enable pins on these two switch mode converters, so that you could actually switch on and off these two supplies using those two pins. You'd have to look at the data sheets for these two chips to see what the polarity of these are and what the voltage levels need to be to turn these two chips on and off. So this item is this. It's a hi-fi low noise single voltage to positive and negative regulated power supply module. This one is $7.93. It's saying buy another, so this is the actual one I bought, even though it seemed to have dropped off my purchase history. Free shipping, and this is from Liang. Now, is it only 5 volts in, or is it different? Let's have a look at the spec of this device, which is down here. Okay, so it's a USB interface or DC 8 to 18 volts in. Output voltage is 8 to 18 volts. Well, it actually went up to 30. Maximum output current 1.5 amps. That's surprising, but there it is. And the board is 41 millimeters square. And yes, you can see USB. Wait a minute. It looks like E+, E- are the input USB or direct welding wire, not the enable pins as I thought. And there's the output, ground in the middle, and the positive voltage and the negative voltage either side of it. Right, here's another one from ages ago. I do know what this is because I've written it on the other side. The question is this going to be in my purchase history? It is quite old. It's an LED watch kit. Yeah, so this is a kit. I just fancied throwing this together on a lazy Sunday afternoon or something like that. Yes, it comes with a garish pink strap and one of these laser cut acrylic multi-layer cases. There we are. We have an STC microcontroller. What's causing my camera to go so dark? Probably that white. Okay, so STC microcontroller, and that is almost certainly going to be a real-time clock chip. Should we have a closer look at that? Yes, that's a DS1302, and without looking that up, DS, I think, stood for Dallas Semiconductor, although I've got a feeling they were bought out. I can't remember who by now. But, oh, was it Maxim? Might have been. But there's a DS1302 there. That's going to be a real-time clock, and that STC ST microcontroller. A little PCB here, which is small enough to fit on your wrist, presumably, and a dinky little 7-segment, quad 7-segment display. And there's the crystal. It's going to be a 32.768 kilohertz crystal. If you divide 32768 down, 16384, 8192, 4096, 2048, 1024, 512, 256, 128, and so on, 64, 32, 16, 8, 4, 2, 1. You get down to 1 tick per second. So that's how you, from a 32.768 kilohertz crystal, you can get a 1 second subdivision. Of course, the microcontroller will do all that stuff. Where's the microcontroller gone? There it is. And give you seconds counting. It also comes with a full set of instructions in English with circuit diagrams, PCB layout, and also assembly instructions for the 6-layer case. Right, so sling that in with all my other electronic kits. Got quite a few in here, actually. I must start getting back into making these electronic kits. Right, well, the one I bought is no longer for sale. I bought it from TomTom's shop. But here's another one, very similar. DIY SCM, not sure what SCM means. LED digital watch electronic clock kit with transparent cover. $9.99, free shipping. And this one is being sold by Kiss Buy. And so these are today's random postbag items. Now, a couple more videos up here. If you like watching my stuff, subscribe using this icon here. And this takes you through to Patreon if you'd like to support Julian's Postbag videos. Cheerio.